Hello friends, today's question is a salient pole synchronous generator with XD is equal to 0.8 per unit, XQ is equal to 0.6 per unit is given, and it is supplying full load at rated voltage and 0.8 PF lag. The power angle and excitation EMF we have to calculate for this condition. Okay, so you can see here that a phasor diagram is drawn. Here E is leading V because it's a generator operation. Okay, and E is the thing that you have to calculate, that is the excitation EMF. And you can see here that there is a dumbbell like structure which represents the rotor. Okay, the the line which is parallel to the axis is the D axis, and the line which is perpendicular to it is the Q axis. Okay, so how to proceed for this kind of question? You can see a phasor here again. What you can do here is this angle between E and V is delta. Okay, and the angle between E and I is psi. So if we are able to calculate this delta and this value psi, then we can calculate the required excitation EMF and the power angle. Okay, so you can do it in two steps. Okay, first what you can do is you can find the value of delta. How you can do that is if you do this thing, if you write E dash, okay, you can find this vector E dash, which is going to be V plus, okay, I into XQ. Okay, JIXQ. Okay, so if you find this will help you to locate your E. Okay, this, if you do this, you will reach the line or you will locate your angle delta. Okay, so once you find this angle delta, now only thing that you need to do is you need to add or subtract something to reach to E. Okay, so what you can do is once you have found E dash, okay, in that magnitude of E dash, if you add, okay, if you add uh, XD ID into XD minus XQ, okay, ID into XD minus XQ, then you reach your E. Okay, so you can say that it can be done in two steps. Okay, so the first step is, let us do from the first step. The first step is E dash is equal to, okay, V plus J I into XQ. Okay, now you know everything here on the right hand side, and you can substitute it. So let us consider V is equal to 1 angle 0 degree. Okay, we are considering it as 0 degree. Okay, and so our current I is going to be 1 angle minus cos inverse zero point 0.8, because see, it's a lagging load, so this angle phi, okay, is going to be minus cos inverse 0 point 0.8 if this V is 1 angle 0 degrees. Okay, and XQ, okay, the magnitude is 0.6. Okay, now if you substitute this here, you get your E dash is equal to 1 angle 0 degrees plus 1 angle minus cos inverse 0 0.8 into, okay, this is 0.6 angle 90 degrees, J, because J is going to give you 90 degrees. Okay, now if you calculate this thing, you get your E dash. Okay, after using your calculators, you can you can find that this is equal to 1.44 angle 19.44 degrees. Okay, so now what you have exactly got is, if this is your E dash, okay, and this is your V, this angle you have got, okay, delta, and this is going to be your power angle. Okay, so now what you have done here is essentially you have reached your axis along which E lies. Okay, now this delta is now we can safely say that this delta is 19.44 degrees. Okay, so we have found delta 19.44 degrees. Okay, now once you have your delta, what you need to do is, now you need to proceed to find E. Okay, now again if I draw the phasors here, this is your E axis. Okay, say this is your V and this is your I. Okay, now you already knew this angle. Okay, this angle was uh, again cos inverse 0 0.8. Okay, so this angle was known to you. Now this angle is also known to you, which is 19.44 degrees. So this entire angle which I was saying as psi is known to you now. Okay. Okay. Now what you can do here is you can find this these two currents, the current along this is q axis and current along d axis. Okay. So current along d axis, if you find the current along d axis, okay, it can be shown like this is your angle psi. Okay, the current along d axis is equal to I sin psi. Okay, so if I write current along d axis id, it's going to be I sin psi. Okay, so now that current id is going to be I is 1 per unit and sin psi is 19.44 plus cos inverse 0.8. Okay, so now if you calculate id here, and what you get id here is 0.8 0.832. Okay, so this is your id. Now once you have your id, what you can do is your mod of e, okay, this is the magnitude of e, is going to be mod of e dash plus id into xd minus xq. So this is xd minus xq. Okay, remember that this is only mod. Okay, you don't have to use any complex numbers here, just use the mod. So e is, the mod is 1.44, we have calculated earlier, plus sorry, e dash is equal to 1.44, we have calculated earlier, and id is equal to 0.832 into this xd minus xq, if you calculate, is 0.8 minus 0.6. Okay, now if you calculate this, this comes out to be 1.60. So your e is going to be 1.60 angle of 19.44 degrees. So your excitation EMF is 1.60, okay, in per units, and your angle is going to be 19.44 degrees. Okay, so this is how you need to proceed for these kinds of problems. So thanks for watching.